Yeah, I was leaving it overnight. I didn't plan on doing it, but I talked to my friend on the phone for like an hour and a half, and after I was finished with that, I was like, I don't want to do this. So I just did it. I went to bed instead. Priorities. No, it was really cold this morning. What do I wear? I know, I put on too. I put on my coat? It's annoying. Yeah, it's the worst. Yeah. That's my sweats in my room when I left for staff this morning. Uh-oh. They went back into the lunch and I just realized I forgot it again. Oh, what are you doing?
Hi, Madison.
Just to get back in the
Hello, Meg. We have one handout on the front table. If you'll grab one, please.
Yeah, so keep annoying my roommates because I live on the third floor. Oh, no. Thank you. Oh my gosh. Thank you so much. I'm feeling it today, you know? Yes.
Meg and Madison are here. Sarah is here.
Yeah, so she like got up at like dawn. Yeah. And whenever I'm really like sleeper, so whenever like someone's like moving around the room, I'm like, oh, and then I just fall back asleep. I'm like, it's really early.
Hi, Abby. Hello, Sarah.
Especially during rush hour. Oh yeah, it's the worst. And all the construction going on in Columbus right now. Every time I have a doctor's appointment there, it's like I leave an hour and a half.
Yes, we have one handout on the front table.
Yeah.
Oh, grab one, please, Sarah.
It's here like more than usual. Yeah. And like every time I go, there's like some new construction thing somewhere, and I'm like, why is this here? My sister goes to Ohio State, but she lives off campus. And so
Hi, Sibel. We have one handout.
Like, I hate it. Like she has to leave like 45 minutes before her class. She's there on time. Because like geographically they're very close. Oh my gosh. To drive there because construction traffic all the time. Yeah, no. I went to go see this for and it was like I left like really early because my roommate was like, oh yeah, there's construction like on all these things. And I was like, oh my god, like it's the worst. Terrible. Where's Brandon? Is that in New Orleans?
Hello, Alex.
Okay.
We have one handout. A table of contents.
That's like right on the edge. Yeah. Wheeling and then it's right up. It's really right there. Yeah. They're really easy one to get to. Oh yeah. So usually, like every time I go there, the hospital I have to go to the side. So it's 270 north, so you have to take 315 south and 50 down, right into the heart of the And then
my GPS took me down that ramp like on my way here. I dropped my sister off in Miami and then came here, and my GPS like flipped out when we got like over the city. And it was like, take this ramp, and I was like, hey. So I took the ramp like right down to the city, and I was like, why did you tell me to do it?
yeah. Yeah. How far is it from Miami? Like 2.5 hours. Oh, yeah. I'm driving to again. It's fun. Yeah, I just got to there. I think there was a thing to visit. Oh, that's kind of time where I'm like, it's bigger than this. Yeah, basically what it is. Yeah, you can have this explain your way around. I have really good. It is really good. 15 dining options. Wow. Yes, please. Yeah, I did help my friend at OU. Like, I think our sophomore year. It's weird because any leftover meals they have, and they turn into money. They can use like all of the little markets on campus. It was so nice. She was like, "You don't have to eat here. You can just like use the meals and it's like money."
Hey, Zach.
I'm gonna have to listen to them today.
When I go back,
I said real good to a child the other day. I was like, no.
I wonder if you can put in a call. We have. Yes, they can.
All right, thank you.
Okay, sorry. All right.
It needs to be
It needs iron. It needs water.
I think she's just going to stay somewhere. Okay. I never saw her. I was. Sorry.
Yeah, I think it's the 26th.
Oh, okay. Yeah, today is 26. We're done like 20th. Probably that's when I go home. So yeah, I'm not moving today.
Fly by. I know. Faster than we wanted to. Yep. Always.
Well, I have a 10-minute advantage on that one. Oh, he's not in class yet,
Okay, we have 12:30, so why don't we get started? Good afternoon, S&P. Welcome back from fall study break. I hope it was restful. I hope everybody found it very rejuvenating. I wanted to thank you for your excellent writings on Pingelap. That's always a lot of fun for me to read about Pingelap. I think it's a terrific story, and a lot of people were very moved by that. I could tell from your writing. So thank you for your good writings, as have all been returned to you through Blackboard. One announcement about that, we are going to have a tribute to Oliver Sacks on Thursday, October 29th. You might remember that I mentioned that Oliver Sacks died just at the beginning of this semester, and he's a person who wrote that particular chapter. He's written many important articles and chapters and books in neuroscience and neurology, and a lot of psychologists are very inspired by his writing. So we're going to have a tribute to him on Thursday, October 29th at 4:30. It's going to happen over in Burton Morgan, all the way downstairs in the lecture hall there, room 115. So if you'd like to mark your calendars, we'd love to see you. Very interesting fellow as a neurologist, terrific writer. He also had very interesting experiences as a gay man, and he has a lot to say about music in the brain. So we're going to have a broad range of folks talking about the life and work of Oliver Sacks. So I hope you can join us on that day. Okay. Right now, this cursor is not working. My mouse is not working. So we might be interrupted by somebody from IT who will come over and plug that in. But what I was going to project for you is something that I probably didn't need to project, but I wanted to make sure that you're all on track for Wednesday. We do have another TED Ed coming up, and this will be a TED Ed that will be on depth perception. So we're making our way across the different features of vision. We've talked about color. We've talked about form perception. We'll be talking about depth perception on Wednesday, and there is a TED Ed that's ready to go for you there. We'll have lots of demos also on Wednesday that students typically find fun. And then on Friday, we'll be talking about a particular kind of depth perception effect called the Pulfric effect, which is very, very illuminating, and it's probably my favorite demo of the entire semester. So looking forward to this week talking about depth perception. This time around, we have some conversation about what I will call form perception on Dr. Jessica Witt's articles. So I hope people were able to find all of those and write about them. I did see lots of great responses on TED Ed, so thank you for that. What I think we'll do is have some conversation about each of these. Hey, Jeremy, thanks very much. Yeah, I seem to have a dead cursor over there, so if you could wiggle that around and figure out what I've done wrong, that would be very helpful. Meantime, why don't we go right into the Jessica Witt article. So I wonder if we can first have a volunteer, if we could, while the class is talking about this. Could we get somebody to come up to the board and jot down what you did on Draw 2 the other night? You were drawing a picture of the poster that she was using to get all kinds of responses from her participants. Would somebody be kind enough to do that? Okay, I'm sorry, Liz, if you can come on up, please, thanks. Liz will draw that. Thanks, Liz. And then while she's doing that, I wonder if somebody can help us out in understanding the article's point about grapefruits versus aspirins. What was going on there? Grapefruits versus aspirins. Okay, we'll go with Claire.
The grapefruit versus aspirins thing was was just an illustration to demonstrate in broader terms what might be seen by the people that were swinging at the ball.
Okay.
People that were hitting well would hit as though they were seeing a grapefruit, and those that were seeing poorly shot at like what would be seen at Casper.
Yeah, right. So they're all looking at the same physical target, right? But sometimes it feels like it's this big grapefruit. Other times it's actually smaller. Just subjectively, how many of us have played some kind of ball sports? Okay, at some point, and maybe you've had better or worse days, or better or worse moments with the ball. How many of you have had that kind of experience? Sometimes the ball feels larger or seems larger than it actually is, or sometimes it seems smaller. Has anybody had that experience? Some people have not really had that experience. Okay, is anybody skeptical? Did that work?
Yes, it did.
Okay, thanks so much. I really appreciate it. Is anybody skeptical about the claim that it really does look bigger or it does look smaller? Yeah. You're skeptical?
Yeah,
okay.
I guess I am for certain sports. Like, it makes sense to me for like baseball and stuff, but they tied it in with tennis, and I didn't really see that.
Okay, now you're actually a fairly accomplished tennis player, right? I mean, you play with the varsity team, okay? And does it look bigger or smaller to you, or not really?
I don't really pay attention. Like, I pay attention to the ball, but not the size of it.
Okay, right, okay. All right. Yeah, now I don't know how frequently it is the case that somebody would normally swing and miss at a tennis ball. I mean,
you can whiff.
You can whiff, yeah? Okay. I'm just going to close out some of the background noise here. Okay. Anybody else skeptical about this? Skeptical about the claim? Well, I guess the interesting thing is that in psychology, it's always a challenge to figure out what is that person seeing. We can talk about what we might describe as a type B experiment. Can somebody remind us what we meant by type B? This was not one of the questions, just a little bit of review. We talked about type A experiments versus type B experiments early on. Right? Okay.
Type A had a verifiable answer.
Uh-huh.
Type B is going off of sort of opinion, I guess.
Yeah, right.
Can't be verified.
Right, so in a type A experiment, we do have objectively verifiable answers. We can say that somebody made an error or not according to some standard that a third party could actually measure, right? But if you're getting into a type B experiment or a type B study, then we can't really be sure. They're claiming that the ball is looking bigger. It's as big as a grapefruit. It's as small as an aspirin, okay? Now, they might actually be having that perceptual experience, right? But we don't know. And I think one of the great challenges in psychology is how do you make the unknowable in some way positivistically demonstratable. Right? How can we show that this is the case, that this person really is having that percept? So this is one of the challenges. Okay, so we see what's going on over here, and we have all the different kinds of ball sizes, and your job would be to point to which one do you think best matches the size of the ball that you were just hitting, hours ago or minutes ago. Right? So that's what they're using, and there actually could be something. One of these could be physically correct. Okay, and you can measure the extent to which they departed from that. It might be that all of them are incorrect, and half of them might be larger than the actual target, half of them might be smaller than the actual target. Right? Okay. Okay, so we have the phenomena down. We're not sure. Some of us are skeptical. Some of us are not. We have our poster there. Let's go on to question 3, which was, why did the researchers have participants estimate the softball size before responding to questions such as number of at-bats, hits, walks, age, sex, win, lose? Okay, now we'll go to Jess. Okay, great. Now, there's a wonderful phrase, demand characteristics. That's exactly what's going on, right? Demand characteristics. But in this class, everybody has to have had Psych 100, and we may or may not have talked about demand characteristics in Psych 100. Many of us have had Psych 200, and Jess is appropriately using a term from Psych 200. So could you remind us, Jess, what you mean by demand characteristics, just generally?
It's like when a participant figures out what you expect from them, so they either answer to agree with you or purposely disagree with you. So kind of skew your specific thing what they want.
Yeah, right. So it is the case that our participants will sometimes be influenced by what they believe that we're expecting of them. We call these demand. What they believe we are demanding of them or expecting of them, and hence the phrase demand characteristics. So you try to get away from all of that. And it seems simple, but actually that kind of maneuver that Jessica Witt had taken here was one that was adequate to help this get published, right? Had it gone the other way, had she done that randomly, sometimes she asks about ball size, before or after she had you report what you were doing with your hitting, probably the reviewers would not let it be published, right? Because you would have to control for these demand characteristics. How many people follow that? Does that work? Okay. So a pretty simple step, but also a very important step. Okay. So what we haven't talked about is the study's main finding. Okay. Can somebody help us with that? What is the main finding from this very, very brief article? It's only like 2 pages long. We've kind of alluded to it already. The main finding, we'll go with Meg. She's had her hands up a couple of times already. Thank you, Meg.
They found that there was a relationship between perception and performance, that when people performed better, they perceived the ball as larger.
Okay, right. Mm-hmm. Right, so that was generally the finding, right? So even though it's always the same physical ball, if you're performing better, you're picking more grapefruit-sized items over here, you're picking less aspirin-sized things over here. So there seems to have been some correspondence there. Now, that might, I think most people are fairly persuaded by that. I mean, people could be putting us on, but remember that they made this selection before they reported how they were doing. Right? And we get this kind of a bias where the people who actually are hitting better are seeing the ball as larger. At least that's what they're reporting. Okay, so that's the main finding. And actually there are many studies on topics like this, and we'll have her second paper is similarly oriented. Okay, is this research article better described as an experiment or as an observational study? This was question 5 from TED Ed. Okay, so why don't we go with Melanie?
I said that it was better described as an observational study because no variables were manipulated, and in order for something to be an experiment, they have to manipulate some sort of variable.
Okay, all right. So Liz also had a hand up, and Alexa had a hand up. Anything to add to that, Alexa?
No.
Okay, all right. So just by a show of hands, how many people thought this was better described as, so the choices are experiment or observational study. How many people thought it was better described as an experiment? It's okay if you did. And I think they call it experiment 1, or in one of the articles they refer to it as experiment 1. And we throw that word around a lot. How many people thought it was better described as observational? Okay, right. And again, this is probably a distinction that we learn to really stand on when we're in Psych 200, and I realize Psych 200 is not a requirement here. So for those of us in the room who have not had that emphasis really laid out for us very clearly, I think Melanie got it just right. That there really is no manipulation here. We're just making an observation about how well they're hitting and what they're reporting as the ball size. Okay, we're not getting any feedback on that. Just pick the one that's working the best. They can pick any one that they want. Okay, and we're observing how they were doing on their hitting, and we're looking at a correlation between those two. Right, so we're not directly manipulating anything. Nobody was assigned to one condition or another. That's another indicator typically of an experiment. You have some kind of assignment. Okay? All right, we also have question 6. So we'll have you briefly summarize the gender effect. We'll start out just with that much. Somebody help us understanding what the gender effect was. Alex has something on that.
Was it that males perceived the ball as larger despite batting average being the same?
Yeah, right, okay, so very interesting. So on average, males were picking larger ball sizes than their female counterparts were, but there was no difference in batting average, okay? First, how many people are just following that statement? Is that working for us? Okay, so the men are reporting that it's bigger, okay, but they're actually not hitting better or worse. There's no statistical difference in observed behavior, but there seems to be a perceptual difference. How many people find that puzzling? Anybody find that puzzling? Anybody not find that puzzling? And how many people are not sure what to make of that? Okay, all right. For those of you who reported that you find that puzzling, can you share your befuddlement with us? Why was it the case that you find that puzzling? So the men are reporting larger softball sizes than the women are, right? And there's no difference in their batting average. What surprised me about that, and this is just my take on it, was that seems to almost go against the theme of the paper, right? It should be the case that if you're seeing larger baseballs, that would be associated with better batting averages, right? That would typically be the case. Okay, so you might have guessed that people who are seeing this as being larger would have better batting averages. The men were seeing it as larger, but they don't have better batting averages. I thought that was quite peculiar and almost contrary to the theme of the paper. So I'm glad that you reported. It was a very honest report, right? A very honest report indeed. Does anybody have an idea about how we might be able to explain that gender effect based on what we learned in visual anatomy? We learned all about the different properties of the retina and the ganglion cells and the optic disc, and then that went off through the optic chiasm to the LGN. We went from the LGN through the optic radiations off to primary visual cortex. We learned about different kinds of cell types. There are a simple cell, a complex cell, a hypercomplex cell. So we did a fair amount of visual anatomy over a couple of days, 2-3 weeks ago. Anything about the visual anatomy, visual physiology that you think might explain the gender difference? Yeah.
I don't know if this is correct. I kind of just took stuff and said that maybe females have like a tilt after effect from kind of like, because he associates like females with softball and males with baseball, and baseballs are smaller.
Wow.
Like males are used to the smaller stimuli, so when they get a bigger one, they're more.
Wow. Okay.
Females are less sensitive.
That's enormously creative. I've not had anybody in several years generate something like that. But that now you're going to push me into telling a story here that I think is a really, really fun story. And I wasn't planning on it, but now you're reminding me of a really, really good one. My answer on this would have been something like, there's absolutely no evidence whatsoever to suggest that there's any physiological difference. I mean, men and women have eyes. Men and women have retina. Men and women have blind spots. Men and women have LGNs, V1s. The paths are identical, right? I can't imagine a physiological reason why this is going on. I love this possibility of some kind of long-term tilt-after effect now for size perception, right? So we're used to seeing something of a set size, okay? And now it's bigger than it normally is. Maybe that seems like an exaggeration to the men. So they're actually exaggerating, this thing was way bigger than usual, and so they're hitting it bigger than it actually was. I mean, that's really clever, right? I've not heard that. And I've had the conversation with other vision scientists, and nobody's generated that. So maybe we're on to something. So here's the story, just that Meg has prompted me for. And it was really interesting that during the All-Star game, there was a home run competition. Has anybody ever seen those home run competitions? So before the All-Star game starts, you've got all these heavy hitters, right? These are the best hitters in the league. So they're throwing them these pitches, and the pitches, I think, are coming from a machine. So you have some idea about where the pitch is going to be landing, and they just have the guys hit as far as they can, and the question is who can hit the longest home run, who can hit the most home runs, and that's the ball game there. So they're doing that before the All-Star game starts. One year, a couple years ago, they brought on a softball pitcher. Does anybody know this story? So instead of baseballs, they did the baseball thing, but then for kicks, they brought on a female star softball pitcher, who I think is from Ohio, interestingly enough. Did anybody hear about this? Well, some of the all-star players got a little bit arrogant, and they were saying, well, this is going to be really easy, right? Because a baseball is only this big, a softball is much bigger, and a baseball is thrown at something like 90 miles per hour, whereas a softball is going to be thrown at 60 miles an hour. So it's slow and it's big. I'm going to knock that thing out of the park. I mean, some of these guys got really cocky, frankly. But they were just, and you can imagine that there's a bit of a gender thing happening here, right? There's a woman throwing this pitch, and she's throwing a big ball 60 miles an hour as opposed to a man throwing a small ball at 90 miles an hour. So the first guy, who is really arrogant, steps up to the plate. In comes the pitch, and he goes flying out of the batter's box. He couldn't hit it, couldn't swing at it. He went flying out of the batter's box. And he tried it a couple more times, and he just couldn't stay in the batter's box. So not only did he not hit the pitch, not only did he not swing it, he couldn't stand there. And the reason is very much akin to what Meg has got onto here. And the idea is that normally this guy has taken tens of thousands of pitches for a particular stimulus. Okay? And when that stimulus is back where Sibel is, it's at a particular spatial frequency. As it's coming closer to me, it's getting bigger and bigger and bigger. As you might expect, it's getting lower in spatial frequency. Who's okay with that so far? Okay? After you've seen, tens of thousands of pitches, it would normally be the case that you wouldn't be bailing out of the batter's box until something got really, really close to you. And if it were really close to you, it would have a low spatial frequency. Who's following that? Okay? Well, now here comes a very unusual stimulus. It's not a baseball, it's a softball. Okay? And it's coming in at a pretty good clip. Even though 60 miles an hour is slower than what the baseball typically is, it's still a lot bigger. So on his retina, that thing, his distal stimulus is out here, but his proximal stimulus is now so big, this is now reaching what you might call the bail-out signal. Right? Had that been a baseball, and had that been that big on his retina, it would be time to bail out of the batter's box, right? Who's following that? Okay? And he just couldn't stand there anymore. He would try it, the ball would come in, and by the way, the ball was nowhere near him. It was right over the plate. It was beautifully thrown. Okay? It would have been a strike, but he just couldn't stand there because he kept on feeling like it was going to hit him. Okay? So this is very clearly a learned response, and it looked bigger to him than it actually would have been. So maybe you're onto something. Okay? That's great. I'm going to have to share that with some other folks. Who's following that phenomenon? Yeah? Okay, so very much a learned effect. Let's go on to question 7. Does the study pertain more to the midpoint or the slope of a psychometric function? So we haven't done those in a couple of weeks. Slope or midpoint of a psychometric function? Let's take a little vote. How many people think it's more about the slope of the psychometric function? How many people think it's more about the midpoint? How many people are not sure? It's okay if we're not sure. Okay? I'm leaning midpoint. Anybody want to help us out for how? Okay, we'll go with Sarah.
I said mine, the midpoint represents the amount of the bias, how far away it is from the midpoint on the x-axis.
Okay.
And that's kind of what the researchers were exploring in the study.
Yeah, it's if you will, an inaccuracy. It is not an imprecision. It is an inaccuracy, right? So the idea would be that there really is a correct ball size at some point, and we can measure how far away you are there. Okay. And now maybe you're actually seeing it as smaller than it is or larger than it is. That's kind of type B-ish, we can't say, but we actually do know how big each one of these is, and we know how large the ball is, so we can make a measurement of how far off you are. Now, whether you're actually reporting what you're seeing or whether you're pulling our leg, we can't really know. Okay? But we can measure that departure from some kind of midpoint, and that's very much what's going on in the point of subjective equality in our psychometric function. Who remembers that phrase, point of subjective equality? Does that sound okay? That's all about the midpoint. Okay. Can somebody help us out with how this study pertains to the approach that had been advocated by J.J. Gibson? And we learned about him way back when, third or fourth class of the semester. Right? We learned about theories of perception. Anybody want to connect this to J.J. Gibson? I think that Dr. Witt herself would tell you that she falls pretty strongly into a Gibsonian school. Okay, thanks, Meg.
Well, I'm kind of looking at addition with the affordances that he talks about and how it maybe the positive and negative and the ball and like how the animal can act on the environment and the environment can also kind of act on the animal. That's when like the ball would be in our environment and we perceive that size like differently, so we take that name and perform accordingly to that environmental stimulus.
Okay, right, yeah. Okay, so we can think of an affordance as what the environment is offering us, and invitation to act is one of the ways of thinking about that. Okay, so I think that's a very important Gibsonian point. Something else that Meg mentioned in her response was that there's a strong emphasis here on action. Right, so this is very, very Gibsonian. The notion that how we are acting is very important to our perception. And we can think about this being a two-way street, that when we perceive something in the environment, we might say to ourselves, aha, that's an opportunity to act. But as we're acting, maybe the action itself actually influences our perception. Okay, so our actions can influence our perception, and her particular operationalization of that is how you're batting, relatively well, relatively poorly, how you're batting might be influencing how you're perceiving ball size. Okay? So the idea would, from other perspectives, would just be, well, the ball is always the same size on your retina. So you'll same input, you'll get the same output. But her take is, well, Gibson would say that perception is for action, and there's going to be a lot of give and take between action systems and perceptual systems. And it might even be the case that how we are acting will influence how we are perceiving. Who follows that? A pretty clear Gibsonian idea. Okay, so those were the questions for the very first article that we had. We could do similar questions for the second article. I did want to try something a little bit differently though today. We've not done anything like this before, but I wanted to see if we can get it, and I was somewhat dependent on the technology. And if I can get it running, I would like to show you the video that I told you did not have to watch, and you did not have to watch it. But I want to see if I can get out to that video. And what we're going to do is watch a few minutes of, it's probably 15 minutes long, of Dr. Jessica Witt in her S&P class. Okay? And what you have in front of you is our table of contents. Right? How many people recognize that as being our table of contents? And if you don't have one, please grab one now. I'll give you a moment to grab that while I call this up. And what we're going to do, and people will tell you, professors will tell you that this is always an important trick in making it stick, making the information that you learn really stay with you. Okay, is that it's important that we review from time to time. So what I've done here is given you the table of contents for our own course, and you've done all of these except for the very bottom one we haven't. That's the one that you'll do for Wednesday. Okay, but what I'd like to do is play a clip from Dr. Jessica Witt's class on sensation and perception. And this isn't necessarily on any one of these topics, but as she's speaking, she'll introduce some things you haven't heard before. She'll also introduce some things you have heard before. I'm wondering if you can make connections between the things she's describing and anything we've talked about so far this semester. And let's get to jot them down. She mentioned this, and that reminded me of this other thing. So we'll see if you can make at least 3 connections. And I don't have any 3 in mind, but I want you to be thinking about this as your prompt. And this is a chance for us to practice. We do like to have what I call a flipped classroom, where in class we're actually doing some practice. So I'll show you her as she's doing her S&P class, and feel free to pull from any one of these and see what kinds of connections you can make. It's an important review tool. I think we'll probably get more out of this than we might have out of the second article, although the second article was also very good. Okay? Who's following that? Okay, we're going to jot down some connections here, and then we'll take a few minutes and see how people were able to connect to another professor's S&P class. I think it should be fun. And we'll probably let this go for maybe the full 15 minutes or almost that long.
Can you hear me? Back? All right. So last time we started with what some common things people believe that to be true about perception that's not really the case. And the list is up here. The first one is that we have this impression that we see everything, that we're aware of everything that's visible all the time. And we showed how this is not the case. So for example, when you're looking for something that's right in front of you, that's a good example of how it's right there, it's visible to the eye, yet we don't see it. We also talked about the myth that we see everything as it really exists in the world and as a projection to the back of the eye. Ways to illustrate that these are not true are through visual illusions. These visual illusions are not special cases where it's the only time that happens. They're just illustrative of these points, but these points are true for just about everything. We also talked about this notion of perception being a single system, and that's not true. I give you the example with the visual illusion where we see this visual illusion, but when we go to act on it, our actions are not full, suggesting that there's one system for conscious perception and another system that guides our actions. That's just one example of multiple systems. We actually have a system for seeing in the dark, and it's another system for seeing in the day. We talked about the M cells and the T cells. One of those is a system for seeing motion. So there are many examples of multiple systems in perception. These systems are parallel. They work together. Sometimes they share some of the same resources, but they're best thought of as separate systems. So perception is not one singular thing, but rather comprised of many different processes. And then we talked about perception as being an active process, that you go out and you seek information when you need it. And there's a saying in perception that the world is its own best model. Why recreate a complete picture in your head of something when if you need to know something, you can just go look? It's rarely the case that you're limited in what you can see. So all you need to do is when you want to go look again. So again, perception, we're not seeing everything, it's selective. We're only seeing the things that we need. We're not seeing things necessarily as they are. We're certainly not seeing the way things project on the back of our eyes. It's not a singular system, it's a multiple system, contains multiple systems, and it's an active process. We discussed why perception is important. Perception is critical because it's the only way that we know what's out there in the world. It's the only way to know what exists around us. Without our perceptual system, we would be completely ignorant of anything around us. If something came to attack us, we would have no knowledge of that, no way to defend ourselves. For this reason, perception is key to survival. And again, instead of thinking of perception as a camera that's trying to capture a full image of everything in front of us, a better way to think about perception is what do we need from the environment? What do we need to see in order to survive? And so we made the top 10 list of these things, starting with motion. So it's really critical to see motion. Like I said, we have a specialized system for seeing motion. The system starts in the eye. The last layer of cells in the eye are known as ganglion cells. There's two types, T cells and M cells. The M cells are the cells that allow us to see motion.
Those are magno and P's are parvo?
A separate stream of information related to motion persists throughout the brain. So we have these specialized systems and specialized areas in the brain just for seeing motion. And we talked about a special kind of motion. I'm going to play this video again. You'll see the president duck. Pay attention to the prime minister's reaction. Why does he not react as quickly? Notice how long it takes him to react to the shoes being thrown. And the reason he doesn't react as quickly is that the shoe doesn't come at him. So it does not trigger the system that's responsible for detecting looming objects. There, he tries to block the second shoe, so he does see it. It just takes a while. And it's often the case, especially with perceptual research, you see a phenomenon in the real world, and you want to know, is that true? Is that a real phenomenon? Is there some part of my brain that's actually processing that kind of information? So you create a task in the lab that allows you to study it. And one way to study looming motion is to use a visual search paradigm. And in a visual search paradigm, one of these objects is going to be the target. It's going to be an oval. I'm going to play the video. And the oval is either long, a vertical oval, or a horizontal oval. Now, it's a really hard task to do, so you're going to have to try and focus really hard to do it. So see if you can determine which way the oval is facing. When the thing that was coming out at you was actually going to hit your head, you were much faster at finding and determining the orientation of the target than you were when it was a near miss, something that was going to miss you. And this is evidence that we have this looming system. As an interesting side note, the subjects in this experiment, and I guess you as well, could not tell which of those looming objects were going to hit them or not. They had no conscious awareness of whether the object was going to hit them or not. Yet that object triggered this system and made them faster to detect the target. So this looming system happens at a subconscious level. It doesn't necessarily trigger our conscious perception, yet we still react to it. We also talked about another kind, a special kind of motion known as biological motion. Here you're seeing an array of dots, but yet you can extract all of information based on the way that they're moving because you're so sensitive to biological motion. And in fact, if you try to look at these and not see motion, you can't do it. We're so tuned system to biological motion that we can't but help see a person acting in this display. I also talked about the importance of the perceptual systems for finding food and identifying whether it's edible. In terms of the visual system, we're able to see color. We can see color because we have three types of cones. These are photoreceptors in the eye. These three types of cones are sensitive to three different colors: blue, green, and red. This is what allows us to see all the colors that we can see. And seeing color is important for finding food. It's also important for identifying food and identifying whether it's edible. It can also help in identifying poisonous objects. We also have our olfactory system, which helps us identify objects and especially to identify poison. If something smells bad, then you can reject it before you ingest it, which of course is an adaptive and useful thing. And our taste system, same thing. If you can taste it and it tastes poor, then you can reject it, spit it out before you ingest it. We also talked about our touch system, which helps us determine if there's dangerous things to our body. We have regular touch sensors. This is basically a graph of how many receptors are for each part of the body. So you can see that there are a lot more receptors for the hands and the face, especially the lips, than other parts of your body, making those the most sensitive parts of your body. We talked about the specialized processing for faces. Using fMRI, we know that there are dedicated brain areas for seeing faces. And when you look at a face, you process it in a special way. And in this case, you process it holistically, which means you see how the different parts relate to each other, which is why it's really easy to see the differences between the two pictures when the face is right side up. When the face is upside down, for whatever reason, you don't process it as a face. You process it for the individual features like you would any other object, and then the differences are not as clear. This is known as the Margaret Thatcher illusion. There are two aspects of faces that are especially important to us: eye gaze and emotion. Ways that these have been studied in the lab. For eye gaze, we use a spatial cueing paradigm, where we look at whether a target appears at the same place that the person's looking, that's a congruent case, or whether the target appears in a different location, that's an incongruent case. And we find that people are much faster in the congruent case than the incongruent case. This suggests that our perceptual system is picking up where people are looking. Another task is the visual search task, similar to what we saw with the looming stimuli. And in this case, we found that angry faces are found more quickly than any other expression. So we're very sensitive to angry expressions. We also talked about the importance of being able to localize where things are. The visual system is able to localize stimuli because of the structure of the eye. If there's a problem with this structure, such as if your eyeball is too long or too short, then a single point of light in the world will project to multiple points on the back of the eye, making things blurry. So if you wear glasses or contacts, when you're not wearing them, everything looks blurry. Well, that's because you don't have this perfect match between what's in the world and what projects on the eye. We also use small differences in timing in our auditory system to localize sound. So if the sound is to one side, it'll reach one ear before the other, helping us to localize it. And then the last item on our list was edges or contrast. And the visual system cares a lot about contrast. Actually, all the senses care a lot about contrast. They want to emphasize contrast, enhance contrast. And this is shown with this demonstration here. So those inside circles are the exact same shade of gray. But most people see the one on the right as looking darker. Well, the reason is that the one on the right is surrounded by a lighter border. And because the visual system wants to enhance contrast, it creates lateral inhibition so that you see that rectangle as being darker in order to enhance the contrast border. Where on the one on the left, it's surrounded by a dark border. So to enhance the contrast, the retina makes it appear lighter. The level inhibition is used to enhance contrast and allow us to see areas of interest with better detail. Alright, so this is our list. The top 10 things that the perceptual systems prioritize. And they can roughly be grouped into these 3 categories. Detecting danger, finding food, and attracting nature. And of course, these are the things we need to survive.
Okay, I'm going to stop it there. Turn the lights back up, and we'll give you a moment to jot down what you think is an important connection. Maybe you found several connections there.
How does it do it?
Okay. But I think even in those 12 or 13 minutes, you had lots of opportunities to find some similarities. So we'll let you take a moment to do that, and then we'll share what people had. And we'll go on to one last exercise for today. Okay, a few people are writing, but most of us are not writing. So I think we can just open it up for comments then. So what connections do people make? Hey, Alexa's got something.
When she was talking about the looming, I connected it to our early reading about consciousness and how she was saying that like we would react to it as though it were going to hit us without necessarily being able to tell you which ones were going to hit us.
Okay.
And I thought about in the consciousness reading when it was talking about how like you don't always have to be conscious in the processes because it could be distracting to you or could actually inhibit your ability to act quickly. So if we had to stop and think about whether or not something was going to hit us before we could react, then that would actually probably be harmful.
Great, great. I saw Sarah's hand, then Liz, then Alex. We'll do it that way. Yeah.
I made the same connection. I also connected to the disease where you can't recognize people's faces.
Ah, okay.
You have like a declarative response where you're not conscious that you know the person, but your physiological response suggests that you do.
That's wonderful. So can we all yell out what was the name of that disorder? Prosopagnosia. Okay, so good review. I think Liz and then Alex, and we'll keep it going. So people made all kinds of connections.
I also made a connection to the consciousness article when she was talking about the multiple systems that made me think of the hard problem of consciousness and about how we just can't really figure out how our feelings get processed into thoughts and that becomes an action, and there are just so many different things that we're not aware of in systems, but they're actually happening on like a level that we can't, on our subconscious level.
Yeah, okay. All right, so what was the hard problem? Can somebody concisely, good connection, Liz. What was the hard problem? We have a fairly concise statement about that. Go ahead, Alex.
We know that, we know that subjective experience or sensations come from the brain, but not power-wise.
Okay, I think that's fair. Right? How do we go from firing to a feeling, right, is one of the ways of putting it. Alex also had maybe another comment, or was that the comment?
No, actually,
okay.
Going off the subconsciousness, I was kind of reminded of the reading we did on Helmholtz about subconscious processes where, again, like we perceive something, we perceive it immediately.
Yeah.
And we react to it even though our awareness of it is.
Okay, our unconscious inference was Helmholtz's encapsulation of that. Okay. Other things. We'll go with Abby, then with Zach.
She's talking about like the myths of perception. I connected like how she said that like myths of having like a single system is wrong because I was reminded of the quote, neurons that fire together wire together.
Okay.
And how like you can have different neurons that like fire for like orientation or color. Like they might not be in the same like area, but like they can fire together.
They can fire together, right. And they can do that very momentarily. So they become part of the system momentarily because the environment is demanding it. And then 2 minutes later, the color changes, the orientation changes, and so do their allegiances with respect to their firing rates. Zach had something.
I think the first myth she talked about was the myth that we see things the way they are. So that just reminded me of like the reds in the home, the fact that there's nothing physically red about it. So we're not actually seeing it.
Right, yeah.
understands physically.
Why don't we go with Jake and then we'll end with Meg. I realized other people wanted to get in. Go ahead.
She also touched on another myth that we don't see everything, talked about not being able to see the dung beetle can.
Okay.
There's just stuff outside of our range of perception.
Very good. Yeah, the dung beetle's got some polarized light cooking there that's hitting us, but we can't do anything with it. Meg had something.
When she talked about how like the world is its own best model, it reminded me of, I can't remember what I think it's like the topically organized.
Okay.
How
Okay.
like the ocean like is corresponds to the retina, and the retina also corresponds to like what's actually out there.
Right.
So it's pretty like accurate on how it corresponds to each other.
Right. Great, great. I thought that was going to be the last one, but Melanie also had an enthusiastically waved hand. So why don't we end with Melanie? Okay.
So, as far as like the myth of perception being a passive process, I sort of connected that to the reading that we did where Dr. Heck discussed Gibsonian ideas about perception and sort of the focus on change and action and how perception is an active process rather than a passive.
Yeah, right. Okay. So we need to take into account what the organism wants to do with that information. Okay. Right. Very, very important. Okay, why don't we draw the line there? We have just a few minutes left. We have maybe 5 minutes left. I think that'll be plenty of time. You might remember that you did this once before. This was a metacognition survey. Does anybody remember doing that one on the very first day of class or thereabouts? Well, we're going to do it now that we're at the midpoint. I'll ask you to grab one. Can you do this again? Can you please just put your Slater box on here? This will take about 5 minutes. When you're done, you can put it face down up here, but please really think it through. I'm curious about your metacognition. If you'll take these, pass them down and over, I'll keep them moving because some folks on the door side don't all have. Do you have any extras?
Yeah.
Okay.
You got.
And can we get those over that way, Liz? And here's one for Tawny and Alex. Okay, thank you, Liz. Okay, so Slater box number up top, please. I realize some people are in my stats class, so this is another one that they're doing. Thank you.